One of those weird days. It's not doing it for me. I really can't even tell if it's recording. It didn't do anything. Hey, I'm going to assume it's recording. Welcome to class. All right, guys, I'm going to move this up just so we can have it. Come on now. This is 2A.4.1, and all we're doing is solving systems using graphing, okay? So I'm going to go ahead and save this. I'm going to save this. What? Don't. Technology sometimes gets the better of me. I'm going to just relax. Ain't no thing. Everything's fine in the world. Well, that's not true, but everything's fine in our class. All right, now I'm in here. I can name this. Okay, so I'm going to go ahead and share this graph with you so you can look at it later. I'm going to add a couple things to it. And the main thing here is, there's Hunter. The main thing here is that when we are solving systems using graphing, the solutions we're looking for are the intersection points. Okay, these are like your notes. I'll share these intersection points. The intersection points. So you think of it as, think of, whoa, don't yell it. Say, don't spray it. All right, think of the functions as roads. Okay, so we're just finding the intersections of the roads. Okay. Now, if we were given a function, we would have to graph the functions, but we're allowed to use technology for this, so we're going to use it. Okay, so we're just looking for the intersection points. If you think of them as roads, it's like, where is your car? Where is your car when you're on both roads? So if you're driving down Fruit Ridge, where are you on both roads between Fruit Ridge and Stockton? When you're right in the middle of the intersection. Okay, so these are key ideas here. We're looking at example 2. That's where this stuff comes from. And if I turn on the first function here, 4x plus 1, let's see. This is our y-intercept. So when I look close here, that's why that's happening. My y-intercept is at 1. Because it's plus 1, my y-intercept's there. And then I would look at it, it's 4, my slope is 4, so I would go up 4 over 1. Let's see where that point is. Yeah, 1, 5, that makes sense. Then I would go up another 4 and over 1, up another 4 over 1. So each function is its own road. Now let's see what happens when I add this to it. Oh, that's cool. So when we have this other function, which has a kind of a cool shape to it, we can see some intersection points. So I want you to click on the intersection points and then tell me in the chat, what are our solutions? Remember, where do we find our solutions? Where are the solutions between the red and the blue graph? What do you think? If you click on the point, it'll show you the point, actually. My cat's like redesigning my living room over there. Stop. All right, I'll give you a hint. Right here is one of our solutions. You see, if you click on it, it pulls it up and it shows you on the graph. 0, 1. There's another solution. Good to on. Someone in the chat tell me the third solution. Yeah, there's 3. There's 3. Where's the third? Oh, I know what that is. I bought this little wooden bowl at Ace Hardware or Trader Joe's, and my cat loves this little wooden bowl and like rubs its head all over this wooden bowl. It's like this big. It's the weirdest thing you've ever seen. That's what she's doing over there. Oh, Santana has it. Good. We had the 2, 9. We had the 0, 1. This is our last intersection point. That's our last solution. It's as easy as it goes. Okay. All you had to be told was where they overlap. Where they overlap is, oh, got it, Tavon. Yep, negatives. Where they overlap and intersection is the solutions. Pretty straightforward. Okay. So now I'm going to give you another one here, because you're going to see that it doesn't matter if we have 1, 2, or even 3 functions going on. I'm going to make this one negative x squared plus, whoops, plus 1. Oh, God. Hi. Well, come over here then. Cry over here. Yeah. All right. So where are our solutions? Okay. Where is the one solution, or maybe 2 or 3, the one solution for all 3 of them? For all 3 of them. Where's the one solution for all 3? Just one. And tell me in the chat, where's the one solution for all 3 functions? Remember, it's where they intersect. These are like some crazy roads that some bad city planner created. These roads are wild, they're weird. But where is the solution between all 3? Maybe we should zoom out to see if there's stuff going on we don't notice. Nah, it looks like it's the same thing going on. Remember, the solution is for all 3. All right, nobody's throwing it in the chat, so I'm guessing I need to do good, Tavon. Anyone else? Good, Santana. Anyone else? No? All right. Not sure, huh? Not sure? Okay, here we go. Look, between the red and the blue, I did have 3 different places. Here, here, here. Those are the solutions. Now, when I add a third one, I don't think it's going to go through this point. This would be a solution for my third. If I added this third one and it happened to go through that point, then it would be a solution for all 3. But I don't think that's what we have. No, it doesn't go through that point. The only point that goes through all 3, the only place you could be with your car is right there, 0, 1. You see, it's that easy. It's just where they overlap. Boom, boom, boom. All right, last one before we look at something else. Maybe we'll do a homework problem. Would it work? Let's see, what if I had this? I said, tell me the solution. What is the solution in common between all 4 functions? Is there a solution in common? Now, there's some in common between the purple and like the red function. I see a solution there. But how about for all 3 or all 4 solutions? Is there a solution for all 4? There is no solution. None. If your system had 4 different functions in it, you would graph all 4 and you look, where do they overlap? They don't. Red, so I see that there's some overlap between red and purple, right? Here's the solution for red and purple, right there. I see that there's some overlap for red or purple and blue. There's that solution. I even see there's some solution between green and purple. It's just where they overlap. But look, when we look at all 4 of them, nah, this was our point for the first 3, but this purple line doesn't go through there. So watch, I'm going to change one thing, and then I want you to tell me what the solution is. Oh, God. What is the common solution now? Yeah, there it is. There it is. Good. I'm seeing a few people list that 0, 1 is the solution here. Perfect. Perfect. All right, what happens if I take this one away? Now what is the common solution? Yeah? You meowing down there? I already fed this cat 5 times today. Yeah. She's very picky. You have to mash up the wet food with water. And if you don't do it right, she'll go up to the food and then just walk away from it. And that makes me feel really bad, kitty. You got to care about me, too. Come up here, then. Quit crying down there. Come walk on my desk. Yeah, there we go. All right. He doesn't want that either. Such an entitled cat. All right. I see a lot of people coming up with it. Good. All right, the places that we have solutions, look, for all these three, boom, boom. Right there. Okay? Pretty straightforward, yeah? Pretty straightforward. Okay. So this is the main thing that we have to accomplish today. There are some other ways to solve these. If you wanted to solve and find the solutions between these two first ones here, you could make x plus 1 equal to x to the third plus 1 and solve it. But those aren't the skill set that we're developing for this section. Okay, we're just solving using graphing. And I'm going to let you use Desmos. Okay, so I want to look at one other problem here. Get out of here. All right. Hey, why don't we look at number 7? All right, let's go to the homework page. I'm not going to give you this problem. I'm going to give you numbers 1 through 6, but let's do 7. I believe it's on page 114. And it looks something like this. All right, so when you access this graph later, let me change what it's called. Whoop. All right. So let's put in a couple more functions. We'll put them after this. So click on it and add another. Let's add another expression. All right, I'm going to put in the 2 for 7 here. Let me see if I can do it. Does it allow me to do brackets? No, that's going to put it in as sets. Okay, so let's do number 7. F of x is really just function notation for y. Negative x plus 7. Right, and then I'm going to look where I can see it here. I'm going to turn that one off so it's not spoiling the satisfying outcome of this. Okay, so these first 4 are ones I just did. Let me actually just add another note here that says this one is number 7. Kitty, you probably can handle not eating for another 30 minutes. Still gonna cry? All right. Be consistent, kitty. All right, so below is number 7 from workbook 2A.4.1. And let's put in the other function here. Let's do the next one. Oh man, that one's hard. 2x chevron 3. So look, if you're in the exponent like that, look where I am right now in where I'm marking this down. I put the exponent right there, right? The cursor is still after the exponent, so just push the right arrow, and it gets it back down below the exponent, okay? And that allows us to then go to the next term and input that guy real carefully. Oh man, this one looks more complex. It wasn't as complex. Look, we changed that. +5, it just moves it up. All right. I got my second function. Is everybody able to plug that guy in? We're able to plug it in? Anybody having trouble? Let me know in the chat if you're not sure how to move from exponent or anything like that. Oh, poor kitty. Oh, so sad. Okay. Let's go ahead then and turn on our other function and see what we're dealing with. Whoops. Oh, there it is. God, it's this easy? Yeah. Graphing, solving graphically is really easy. If you have this road, right? This is like the 33 going up the 5, and the black line is the 5. Let's just say that. So where do you have to be? Tell me in the chat. Where do you have to be at the solution of these two roads? Where do you have to be on both roads at the same exact time? Weird. Hi. Yep. All right, tell me in the chat, where's the solution for this? So I can know that you're, not watching Netflix or something. All right, good. Good, Brian. Thanks for the answer there. Anyone else want to double check? That looks right to me. Good, Yamada, perfect. Anyone else? Tavon, that looks perfect. I have like identical answers here. All right. So this is what I'm going to require of you for the homework. So everybody bring your attention back here. When you find the solutions for the homework, it's going to be pretty quick. It's going to be pretty easy, but I need you to document it, okay? So to document it, you need to take a screenshot and paste that, here I would probably, if I was doing this as homework, I would delete all these so it just says number 7. You can add just like a note to write things into our list here. So I would just look for number 7 and then the equations, the highlighted solution, and then screenshot it, right? And you can use the different kinds of screenshot to be able to aim and take just what you want, okay? So I want to see some screenshots like this. You can't see that. Yeah, guys know how to take screenshots. All right, so you just got to take a screenshot of it, put it all in a Google Doc if you want, share it that way. That's how I'm going to ask for you guys to complete this assignment. All right? So let's see what time we have here. All right, we've been here about a half hour. And that actually is all I want to get to for solving graphically. It's really great. So let me know. Thumbs up, sideways, down. I mean, this is just like a little baby lesson. It's just like a little use of tech, really. Okay. All right. All right. Then let's go ahead and stop the recording. You know what? Everyone's here today, so I don't think we're going to need this recording.